In this video, we'll discuss the trigonometric identities. Now, the trigonometric identities is very important in differentiating trigonometric functions. So therefore, we cannot easily find the derivative of any complicated trigonometric functions if we don't have the idea on the identities, because the identities can simplify the trigonometric functions, and we can also expand the trigonometric functions depending on our purpose. So in short, we need to study identities in order to provide the differential of the trigonometric functions using the technique of differentiation, or maybe by the use of the fundamentals of derivative. Okay, so one of the important identities are fundamental identities. This was already taught in our previous mathematics. In fact, in high school, this was already introduced, and we had also this in our previous mathematics. Okay, what are they? One of the fundamental identities is, if we have the sine of an angle theta, then it is just the same as the reciprocal of the cosecant, which means that the sine theta can be replaced by 1 over cosecant theta, vice versa. Another is, the cosine of the angle theta is equal to the reciprocal of the secant theta. And also the tangent of the angle theta is the reciprocal of the cotangent, vice versa. And the tangent theta also can be substituted with sine theta over cosine theta, which means that if we know the sine theta and cosine theta, we can always find the tangent of theta. Or we can replace the sine theta over cosine theta with the tangent theta, vice versa. Another value for the or equivalent for the tangent the angle theta is secant theta over cosecant theta. This was actually used by the reciprocal, the sine and over cosine. No, so therefore the reciprocals, there are also reciprocal identities, which means that if you take the reciprocal of sine, the answer is automatically cosecant of the angle theta. Similarly, the reciprocal of cosine is just equal to the secant of the angle theta, while the cotangent theta is the reciprocal of tangent. Also, the cotangent can be calculated or replaced by a cosine theta over sine theta. Another is, for the cotangent theta, we can replace it using the cosecant theta divided by the secant to the angle theta. So these are one of the important identities introduced in trigonometric functions. So we can use this anytime for any purpose. Okay, so another important identities are the Pythagorean identities. This is very important. Why? Because we can provide from the 2 or more trigonometric functions, it can be reduced into a single only, vice versa. Or if you want to expand it from one term to 2 terms, you can do it using the Pythagorean identities. Another is, the Pythagorean identities are very important. It's because that we can derive another identities coming from this principle. Okay, so let's start deriving what are the Pythagorean identities. Now, from the word Pythagorean, then we need to use the right triangle. And the right triangle is coming from the principle of the unit circle. So please refer on the previous video. In a unit circle, if means we have the radius of 1, then if this is 1, okay, then it follows that at the angle theta, the coordinate of point is x and y, which means that if you drop a line coming from this point down to the x-axis perpendicularly, then that height is y. And the distance from the origin towards the intersected line is the value of x, which means that we have this right triangle. So we will be using this one, right triangle. Now in our previous video, if this is 1, remember, if this is 1, then we can take the cosine of that angle theta. The x-axis can be replaced by just a cosine of the angle theta. Also, y can be replaced by sine of theta. The reason is, if you use the right triangle here, the opposite over hypotenuse sine, then is equal to the sine of the angle theta is y over 1. So y over 1 is just equal to y, which means that y is equal to the sine of theta. While x, adjacent over hypotenuse, it is x over y, it's x over 1, then it's cosine, which means that x is just equal to the cosine of the angle theta. Okay? So, what next? Next is we can, from this, we can use this right triangle using the Pythagorean identities or Pythagorean theorem. So remember, the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of squares of the other sides. So the other sides are x and y in this case. The side opposite to the 90 degrees, the side opposite to the 90 degrees is always equal to the hypotenuse of the right triangle. Okay? So, squaring x added by the square of y is just equal to 1 square of 1. Or, simply, this is equal to 1. But take note that x is equal to what? Cosine of theta. So, therefore, we can say that the cosine square theta plus the sine square theta is just equal to 1. So, this is the first Pythagorean identity. Okay? So, what's the use of this? The use of this is, if you can see in the equations, and it involves this expression, which means if there's a presence of the cosine squared of the angle theta added by the sine squared of theta, we can replace it with 1. And doing that, the expression becomes simple. Why? Because we eliminate this term by replacing it with 1. Why? Because this is coming from the Pythagorean identities. Okay. So vice versa, if you want to expand your expression, then you can, if you have one value, then you can expand it for maybe another purpose. But the common purpose is to reduce we will reduce the function in order to find the derivative in a simplest way. Okay? So, do not forget this identity. This is a very important. Again, the cosine square of the angle theta plus the sine square of the angle theta is equal to 1. Now, look at this one. From this first Pythagorean identities, if we divide both sides by cosine, which means that dividing the right side, right member, or the left member by the cosine square of the angle theta, and also with the other side, square divided by the cosine square, then this will be the result. Now in this case, notice that the cosine square theta can be cancelled out because they are the same. Okay, so this will becomes 1 because this will be cancelled. Okay, so okay, so then what is sine square theta over cosine square theta? This value is just equal to the tangent. Take note in our previous fundamental identity that the sine theta over cosine theta is just equal to the tangent of theta. So therefore, the sine square of the angle theta divided by the cosine square of the angle theta is just equal to the tangent square of the angle theta. And take note that this one in our fundamental identity, the 1 over cosine square theta is just equal to the secant theta. Okay? So this will be our next or number 2, no particular order. This is another Pythagorean identity. So what does it mean? If you can see in the expression 1 plus tangent square theta, then you can replace it with secant square theta. Vice versa. Okay? So this is another Pythagorean identity. So we have this first. Okay? 1. The first derived Pythagorean identity. Then this is the second derived Pythagorean identity. Now, this time, we will divide both sides. The Pythagorean identity number 1, we will divide that with the cosine sine square of the angle theta. So, what will happen? What will happen is this will be cancelled and reduced to 1. While this one, take note, this is cotangent. Okay? This is cotangent. While this one is what? This is cosecant. So, please refer our previous identity. Okay? So, therefore, again, this will becomes cotangent square, and this one is 1. And the 1 over secant square theta is just equal to the cosecant squared theta. So, therefore, this will be our number 3 identity. Pythagorean identity. Take note, Pythagorean identity. And it's coming from what? From the Pythagorean theorem. Of what? Of the unit circle. Okay? The unit circle which produces the right triangle. So from the right triangle of unit circle, then we come up this one, then again obtain this identity 1, the cosecant square theta plus sine square theta is 1. And the 1 plus tangent square theta is just equal to the secant square theta. And the other Pythagorean is the cotangent square of the angle theta plus 1 is just the cosecant theta, cosecant square of the angle theta. So these are the main, the main Pythagorean identities. Now take note that from the main, the secant square theta is equal to cosine square theta, and that 1 plus tangent square theta is equal to secant square theta, and the 1 plus cotangent square theta is equivalent to cosecant square theta. These are the main. From this, we can create another identity. By what? By transposing, for example, you want to transpose this to the right side. This will become sine square theta is just equal to what? 1 minus cosine of sine square of the angle theta. Which means that if you can see this expression in a given equation, then you can replace it with this value, vice versa. Okay? So then, okay. Now what will happen if I will transpose this to the right side? So the result becomes what? The cosine square theta is equivalent to 1 minus secant square theta. So again, if you can see this to any equation, then you can replace it with cosine square theta. So the cosine square theta is just equal to 1 minus sine square theta. So we have another entity. So we created another Pythagorean identity. Now from the second derived identity, if you transpose, okay, if you transpose this tangent square theta to the right side, the result becomes what? The secant square theta minus tangent square theta is equivalent to 1. So you can notice that the 1 can be expanded to a different form. 1 can be expanded with what? Sine square theta plus cosine square theta. Also, 1 can be expanded into a form of secant square theta minus tangent theta. So, depending on your purpose. So you can choose it. Or you can simplify. You can reduce this. If you have this expression in the given equation, then you can replace it with 1. Sine square theta plus cosine square theta is equal to 1. All or the secant square theta minus tangent square theta is also equal to 1. Now, if I replace this one to we transpose this one to the right side, the result becomes what? The tangent square theta is equivalent to secant square theta minus 1. Okay, so we have this another identity. So you can notice that we form different identities from the three major identities. So similarly, if we transpose one to the right side, the result becomes the cotangent square theta is equivalent to the cosecant square theta minus 1. Also, if we transpose the cotangent square theta to the right side, the result becomes the cosecant square theta minus cotangent square theta is also equivalent to 1. So this is another value of 1. Or, if you can see this in equations, then you can replace it with 1. That's it, no? So, all in all, we have 9 Pythagorean identities formed. And take note that these identities, the 9 identities, are actually coming from the sine square theta over cosine square theta. Which means that if you forgot these identities, then be sure to know this basic. This is the starting point of our derivation. The sine square theta plus the cosine square theta is equal to 1. From there, you can generate other trigonometric or Pythagorean identities. So therefore, these are the identities. Now, Pythagorean identities. Now, next is we need to know the sum and difference identities. Why? Because there are cases that your angle, for example, you have the angle of sine. You have the operator sine and the angle forming sum. For example, theta plus beta, or 30 degrees plus 75 degrees. Now, what is how to evaluate that? How to do it? Okay, so there are ways to simplify it, and that it's by means of sum and difference identity. Sum, because we will be using plus, meaning alpha plus beta, okay? Or it can be alpha minus beta, or the angle 1 minus angle 2, or angle 1 plus angle 2. So we call that as sum and difference identities. So we will derive again. Now we need to know the sum and difference identities, because from this we can generate another identities like double angle identity, half angle identities, and those identities are coming from the sum and difference identity, which means that we badly need this sum and difference identity. But the sum and difference identities can be derived from the basic mathematics plus the principle of the Pythagorean identity. So let's start. Okay, now first we have to consider the Cartesian plane. So we have the x-axis and we have the y-axis. So the horizontal is x, and the vertical is the y-axis. So therefore we have this origin. Now suppose we have a line that whose radius is equal to 1. Take note, this is 1. So if you revolve this one, it will generate a unit circle because the radius is 1. A unit circle, it is always a radius of 1. So take note that if radius is 1, then at this point with an angle of beta coming from the x-axis, then we can say that the cosine, the x-axis, or the abscissa, or the x coordinate is just equal to the cosine of the angle beta, and the y coordinate also is just equal to the sine of beta. So the abscissa and the ordinate can be simply take the cosine and the sine of the angle beta. Why? Because this is 1. Now, if we revolve this to the second quadrant of this line whose radius is equal to 1, then the angle from the positive x-axis is now increasing. So suppose we will call this as alpha. Okay, so we have two lines whose length is 1. Okay, so therefore we have another coordinate, no? Another coordinate of point. So the coordinate of this point is just equal to, again, this is cosine of the angle alpha, while the y coordinate is equal to the sine of the angle alpha. Okay, so then if you connect a line that passes through these 2 points, by the way, this angle now becomes what? The angle between these two lines is just equal to the alpha minus beta. So if you subtract alpha with an angle beta, the angle now becomes alpha minus beta. Another thing is if we connect a line passes through this curve, okay, then we call this as the undirected, or this is the undirected distance. So we have the distance between 2 points. So take note that in our previous mathematics, we can always find the distance between two points. How? Now, take note that if you want to calculate this distance, it's just equal to what? The square root. No? The square root of the square, diba? X minus x1. If this is x1, you have to subtract it with x2, then square it. Then it can be added by the sine of the alpha, then minus the sine of beta, then square it. So if you take the square root of that, then the answer is the distance between 2 points. So take note that in the previous mathematics, okay, in the previous math, that the distance, undirected distance, is equivalent to the square root of, so given 2 points, so we have the x2 minus x1, vice versa, then square it, then added by y2 minus y1, then square it. That's it. Okay, so this is the distance formula. So in this case, our x2 is cosine of alpha, our x1 is the cosine of beta, and our y2 is the sine of alpha, and our y1 is the sine of beta. So the distance between 2 points now becomes what? The square root of the cosine alpha, which is in this case our x2, minus the cosine of the beta, which happens to be our x1. So cosine of alpha minus cosine of beta square, plus the sine x, this is y2 minus y1, then square it. So take square root. This is the process of calculating distance between 2 points. Then now take note that from this, if you revolve this, okay, meaning if I place this line along the positive x and maintain this angle, then this will found in the first quadrant. Okay, so in that case, look at this one, but notice the angle. So this angle, remember, is alpha minus beta. So if we maintain the alpha minus beta and maintain everything, meaning maintain the sides and maintain the distance is the same, but place it in the first quadrant, or so that one line, one side, the side of this triangle laid on the positive x-axis. Okay, that's it. Now there are changes of the coordinates. Now in this case, because this is lying on the horizontal axis or the positive x, the coordinate at this point is just simply by 1 abscissa 1, then the ordinate is 0 because there's no y. But this one becomes the cosine of alpha minus beta, and this is the sine of minus beta. So we just rotate, no, from that, rotate it to this case. What's the purpose? The purpose of that is we can generate another distance d, no, between 2 points. So take note that in this configuration we have this distance. Now what is the distance using these coordinates? So use the same principle, no? So if this is your x2 minus x1 square it, then you have to add the sine of the angle alpha minus beta subtracted by y1 or 0, then take square. Then you have to take square root everything, and the answer is d. So therefore, another equation for the distance of the same triangle, but the difference is the coordinate. So calculating again this distance, it is equivalent to the cosine of alpha minus beta minus 1 and square it plus the sine minus beta minus 0, which is this one, then square it. So we have two different values of the distance, but they are, take note, they are the same. We did not change the side, we did not change the angle, remember. So therefore, this d must be the same. This d is equivalent to this value. Now, in other words, in mathematics, we can equate these two. So, equating these two. So, this one should be equivalent to this one. So, we have this as the sign of equality, and they are true. No? They are the same. Now, using this equation now, we will expand this one. So, by the use of the square of the binomial, so you have to expand this using the square binomial. Square the first, twice the first, second, square the last. Also this one, this is 0, so this is simply as sine square of the angle alpha minus beta. While this one, use the square of binomial, and this is also use the square of binomial. So expand it. Okay. By the way, in order to, we need to remove first the radical. So the only way to remove is to square both sides. Yeah? Square both sides. So in algebra, there's no violation of squaring the equation. But take note that if you square the left member, you should square also the right member. And the result is just the same. They are equal, no? They are equal. That's the law of the algebra. So in that case, squaring is actually the removal of the radical symbol. Now in this case, we can now expand this one using the square binomial. This one, square binomial, this one, expanded. So in this case, square the first, so cosine square alpha minus beta, twice the first and second, it should be what? 2 cosine of the alpha minus beta, then square the last. Square the last means 1 squared, and it should be added by 1, so this is 1. But this one, because this is 0, so this is simply as the square, sine square of the angle alpha minus beta. Now this one is again a square binomial. Square the first, twice the first and second, square the last. So it, we use the shortcut way to expand the square of binomial. So square the first, okay, then twice the first and second, because this is minus, this should be minus. Then square the last. So this will be always a positive value. So square that. So therefore, these terms are the expanded form of this one. While this one, if you expand this using algebra or the square of binomial, then this one. Square the first, twice the first and second, square the last. Because this is minus, so the middle term should be minus, but the first and last term should be positive. That's the rule of squaring binomial. So the sign here is by the second term of the expanded form. Okay, so in that case, what will happen is we have this value. So if you simplify this one, because this is 1, take note. So you can notice that we have this cosine square of the angle alpha minus beta. And you have this sine square of the alpha minus beta. Now, remember in our previous Pythagorean identity, if you have the same angle and you have cosine square and sine square, then this should be 1. Okay? So this should be 1. So this value, this term plus this term, because this is plus, this is simply as 1. So therefore, we have 1 plus 1 becomes 2. So this can be reduced to what? 2 minus cosine, minus 2 cosine of the angle alpha minus beta plus 2. So that will be in the left member. In the right member, you can notice that this one, this is cosine of the angle alpha. And take note, we have this sine of the angle alpha. So you can remove this one and replace this with simply 1. So I write this 1. So this one is cosine square alpha plus the sine square alpha is 1. Another is, take note that this is cosine of the angle beta. And we have also the sine square, the square of the sine square of the angle beta. So again, you can remove this one and replace it with 1. So we have 1 plus 1, 2. So what we have now is what? We have this minus cosine alpha, 2 minus 2 cosine alpha cosine beta, minus 2 sine beta, sine alpha, sine beta, then plus 2. Okay, that's it. So 2 plus 2. So this will be the result. So this one is actually in the above result. And this 2, this is the result of adding 1 plus 1 because of the cosine square alpha minus beta and the sine square of the alpha minus beta. So that's why this is 2. Now this 2 again, another 2 is, this 2 is coming from what? This cosine square theta plus sine square theta of alpha. That's 1. Another one is the cosine square of beta and the sine square of beta. So 1 plus 1 equals 2. So that's why this is 2. And this one is this term, while this one is this term also. That's it. So we reduce or simplify the result. Take note that we can cancel this 2. We can replace, because this is positive and this is positive, and this found in the left and this one in the right, so it can be cancelled out. So what we have now is, and if we divide both sides by what? Negative 2. So this can be removed. Negative 2 and this negative 2. So therefore, the resulting equation now becomes cosine of the angle alpha minus beta is just equal to the cosine alpha cosine beta plus sine alpha sine beta. Okay? So therefore, this is one of the sum and difference identity. We call this as the sum, okay, our difference of the angle alpha and beta. The cosine of alpha minus beta is what? Cosine b alpha, cosine beta plus sine alpha minus sine beta. So this is our first difference identity, and this is cosine of the alpha minus beta. So you can notice, for example, if this is 30 degrees and this is 70 degrees, the cosine of 70 degrees minus 75 degrees, then you can expand it through the cosine of the alpha, or 30, the cosine of 75 plus the sine of 30 times the sine of 75 degrees, vice versa. Meaning, if you don't, you can break these angles, no, different angle by using the identities, because it's difficult to work on with this one, especially if one of these variable, for example, is unknown and this is given. So if you want to solve for the unknown, the only way is to use the identity. You have to break the angle formation. So the difference of the angle can be eliminated. How? That's by the use of the sum and difference identity. So this is one of the sum and difference identity. Again, cosine of the angle minus beta is cosine alpha, cosine beta plus sine alpha, sine beta. That's it. So now, again, this is the identity. The keyword, or in order to memorize this, very simple. The cosine of the alpha minus beta, cosine means cos, sin. So it should be the first angle, alpha, and the second angle must be beta. So cos, sin. This is all about cosine, and the second term is all about sine. This is for the cosine identity. So if this is minus, this should be plus, which means that what will happen if this is plus? So this we need to derive another identity. Now, if we let alpha be equal to 0, so what will happen is everything, replace everything by 0 to the angle alpha. So this will become 0, this will become 0, and this will become 0. Now what is this one? This term becomes cosine minus beta. But this one is what? The cosine of 0 is 1. So 1 times cosine beta is just cosine beta. But the sine of 0 is 0. So this, if this is 0, one term is 0, multiplied by another number, the result is 0. So this term becomes eliminated. So what we have now is the cosine, okay? The cosine of the angle negative beta is just equal to the cosine of the beta. So this is one of the reduction. We call it the reduction formula. There are many reduction formulas. Now, reduction formulas are also important because we can simplify, we can eliminate the negative angle and replace it positive, or you can also break the angle that forming sum. For example, the 90 degrees with another angle, the 180 degrees, those are reduction formulas. So we will derive that later. So for now, we have this, the cosine of the angle negative. So what does it mean? That this signifies that if you have the cosine of negative angle, if you take the cosine of that, it is just simply by what? Using only the positive angle. So you can eliminate this negative because this is the result, and we call this as the reduction formula. And this reduction formula was derived because of this identity. That's it. So now, what will happen if I replace alpha? This time, we will replace alpha with pi over 2. Pi over 2 is 90, take note. So this is 90. 180 degrees, sorry. 180 degrees. No, because pi is 1 revolution. So if you divide it by 2, then that is what? 90 degrees. Okay? So replace the alpha here from the difference identities with pi over 2. This is pi over 2. This is pi over 2. This will be the result. So instead of alpha, replace it with pi over 2, pi over 2, pi over 2. Now what will happen is the cosine of pi over 2 is 0. Okay? So recall in your previous video, this is what is the cosine of 90 degrees. Or if you use the calculator and use the degree mode, the cosine of 90 is 0. Which means that cosine 0 times cosine of beta, this term becomes eliminated. But the sine of 90, this pi over 2, 90, is 1. So this is 1. And this will become sine beta. This term becomes sine beta. Which means that if we have the cosine of the pi over 2 minus beta, it's just the same as the what? Sine beta. So notice this one, no? this is 90 degrees. So if you have cosine of 90 minus beta, it's just simply as the sine of beta. Which means in this case that the complement, the cosine of the angle, cosine of this angle, which happens to be 90 minus beta, is just the sine of the complement angle. This is the complement angle. Complement angle. So therefore, the cosine and sine are cofactors. So for example, if you have cosine of 30, now the complement of 30 is 60. So the sine of 30 is just equal, the cosine of 30 is just equal to the sine of 60. That's it. This is the meaning of this reduction formula. This is another reduction formula. So you can minimize this one by replacing. You can remove the negative sign by using this, and you can minimize this angle, the forming sum, a difference, and that will be reduced to theta. That's it. No. So now this time, because we want to, our aim is to produce another identity, sum and difference identity coming from this one. So what will happen is, if you change this beta, instead of beta, replace it with alpha minus alpha plus beta. So imagine that we will replace beta with alpha plus beta. What happened is this one. This will be the result. So instead of having this one, then we expanded it with alpha minus beta. Now in algebra, there's no violation of that, provided that you have to change also this beta with alpha plus beta. So there's no such difference on that. Speaking of equality, they are all the same, equals lah. So the left still equal to the right. So there's no violation as far as algebra is concerned. Now if you remove the grouping symbol here, in this case, the result becomes what? Minus alpha minus beta, and we need to regroup this one. We need to regroup that value. Okay. Now we will use the difference identities of cosine. So this is, take note, this is cosine, and this is one angle minus other angle. So you can imagine that this is alpha. So cos, sin. Take note, no? So we will apply the sum difference identities on this element, the left element. Then this one is this copy. So this is cos, sin. So the cosine of pi over 2 minus alpha times the cosine of beta, because it's minus, so it should be added by sine of this term times the sine of the sine of this angle times the sine of the angle beta. That's it. Cos, sin. So the resulting equation now becomes what? This one. So we have this cos, sin, the cosine of the first angle times the cosine of the second angle. Alpha minus beta. Okay. It should be cos, and this should be sin. So the same angle. Our angle is pi over 2 minus alpha. This is pi over 2 minus alpha. This is beta. And we just recopy this the right side. Now, take note that the reduction formula says of this is what? What is cosine of 90 minus alpha? Remember, cofactor. So therefore, this will becomes what? Sine of alpha. So this will becomes sine of alpha. Okay. While this one, this is cosine of alpha. So that's it. This will becomes, again, this will becomes sine of alpha. This one becomes sine of cosine of alpha, the cofactor. Then just copy this one. See it? Which means that this is another reduction formula. This is for sine. Which means that the sine of alpha plus beta is just equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So this is another, or we call this as the sum identities of sine. The sum identity of sine. So if the cosine is cos cosine sin, then the sine must be sin cos cosine. So take note of the arrangement of the angle. Because this is alpha plus beta, and this is sine, so use the sin cos cosine. So what is the meaning of sin? The sin of the alpha multiplied by the cos of alpha added by, because this is plus, so it should be added. Unlike this one is minus. For cosine, if it's minus, it should be plus. It added by the cosine of alpha times the sine of beta. Now, this is our first. We call this as the difference identity, and we call this as the sum identity of sine. This is the difference identity of cosine, while this one is the sum identity of sine. Now, from this, replace beta with negative beta. So imagine that we will replace beta with negative beta. So what will happen? It should be everything. So all beta in this expression should be replaced by negative beta. So that's it. This will be the result. Okay? This will become minus beta. While this one is what? This is negative. If you take note that the cosine of negative angle is just equal to the positive, the angle cosine. So there's no difference if we have this negative. But take note that this is very important. If the cosine of negative beta is equal to, it's just the same as the beta reduction formula. The sine of the negative beta is equivalent to a negative sine of beta. So the angle becomes positive, but the term becomes negative. This one, if this is negative, you can eliminate the negative, and you can have this as positive. So with reduction formula. So in this case, if you replace with this with negative, the result becomes negative sine of beta. So therefore, this term, the second term, becomes minus. And this is another identity. We call this as the difference identity. Difference identity of sine. This is the sum identity of sine, while this is the cosine. The difference identity of cosine. Now, for the positive, what about the positive identity of sine or cosine? So, okay, so you just change the sign. So if this is positive, this will becomes negative. And take note, cos cosine sin. If this is minus, then this will be plus. That's for the cosine identity. Now for the sine identity, take note of the keyword or memory guide. Sin, cos, cosine. For the cosine, cos, cosine, sin. But take note that if this is plus, this is also plus. Unlike with the cosine, plus, minus, minus, plus. So the difference identity of sine must be what? Sin, cos, cosine. The arrangement of the angle must be in order. In order. No? We have the alpha, theta, theta, or alpha, beta, beta. So this is alpha or theta, beta. And this is sin, cos, and this is cos, sin. Do not change the arrangement. So since we know already the sign of the angle, for example, difference angle, and you have this cosine of this difference of the angle, then you can find the tangent. Remember, from the fundamental identity, that the tangent is just the same as sine over cosine. So if you divide this sine of the angle theta minus beta with this value by the cosine of theta minus beta with this value, the result must be what? Tangent of the angle theta minus beta, which means that By the way, the reduction formulas these are very important. The negative angle beta is positive, so you can imagine that you can erase the negative if it's cosine. But take note of the sign. The term becomes negative. The angle is positive, but the factor becomes negative. Another is the complement angle. The complement of cosine is sine, so their complements must be the same. It means that the cosine of 60 is equivalent to sine of 30. So cofactor. And the cofactor of cosecant is secant. The cofactor of tangent is cot. So their complement must be the same. Trigonometric function of their complement must be the same. So again, we have this. The tangent of the positive sum angle, if we use the positive, then this should be positive. It should be tangent theta plus tangent beta divided by 1. Take note, this is minus. So if this is plus, this is 1 minus tangent theta times the tangent beta. Now, if we have difference, if this is minus, this should be minus also. But denominator, it should be 1 plus. That's it. No? So, with that, again, if you have the cosine and you have the sine, all function can be, in our previous video, if you have the cosine and sine, then all the trigonometric function can be calculated using the fundamental identity. Now, what's the application of this? Why is it that we need to understand the Pythagorean identity, the Sum and Difference Identity, and the reduction formulas, and we have the fundamental identity? The reason is because if you are asked what is the cosine of 75 without using calculator, now using calculator we can easily find this cosine. But what will happen if you are asked, show your solution in calculating the exact trigonometric function of 75 degrees? What will you do? Cosine of the 75 degrees. Now remember, 75 is not a special angle. So in our previous topic, finding the exact values, those exact values are the special angles. For example, the tangent, 30 degrees, the 60 degrees, those are special angles. The quadrantal angles that ended with axes are special angles. So we can always find the cosine and sine by using the unit circle principle, because all special angles can be translated into unit circle principle. And you can use the principle of unit circle with a radius of 1, and we can find the coordinate. If we have the coordinate, you can find the trigonometric function. Now, this one, 75 degrees is not a special angle. So what will you do? And the question is, find the exact value. How will you do it? Now, to do it is, take note that 75 can be break into what? The 75 can be break into 45 and 30. The 45 degrees is a special angle, and the 30 is also special. So if you combine these two special angles, the 45 plus 30 is equivalent to 75 degrees. So with that, we have now the special angles, but the problem is these are forming sum. So the first thing to do, in order to provide the exact solution of the cosine of 75 degrees, then we have to use the cos-sin. That's why we use the sum and difference identity. In this case, we will use the sum of cosine identity. So cosine of alpha plus beta should be cos-sin. So because this is plus, it should be minus. So in this case, this will be the result. The cosine of 45 degrees, okay, times the cosine of 30 degrees, cos. Then it should be subtracted because this is plus. it should be sine of the 45 degrees multiplied, take note, multiplied by sine of 30 degrees. This is also multiplied. Now this time, all trigonometric functions now are having an angle of special angles, the 45 degrees and the 30 degrees. So using our previous knowledge in unit circle, then the cosine of 45 degrees is take note, square root of what? Square root of 2 over 2. While the cosine of 30 is what? The cosine of 30 is square root of 3 over 2. So kindly refer to the first video on this topic of the trigonometric function derivative. So the exact value of 45 degrees is square root of 2 over 2, while the exact value of 30 degrees is 1/2 or 0.5. So replace everything will provides you the what? The exact value of the cosine of 75 degrees. Then all you need to do is to simplify using algebra. Then that's it. Same denominator. So the exact value of the cosine 75 degrees is just equal to the square root of 6 minus square root of 2 divided by 4. This is the answer. That's it. Okay? So you can notice that we can find the exact value even if it is not a what? Even if it is not a special angle. And we grab the opportunity that we can break it into a special angle. So if you can break that angle and forming special angles, then you can provide always the exact value. Why? Because we have the sum and difference identities. Because the sum and difference identities can break the angles, the forming sum and forming difference. And with that, we can apply our previous knowledge in finding the exact values of the special angles. Okay? Now, what else? By the way, the 15 degrees is not a special. Okay? The 75 is not a special, but the 75 can be break into 45 plus 30. The 75 degrees can be break into what? Out of 15 degrees can be break into 45 degrees minus 30 degrees. So which means that we can find the exact value of the 6 trigonometric functions of the 15 degree angle. Also with, we can find the 6 trigonometric functions of the angle 75 degrees. Take note, the 6 trigonometric function can be obtained. How? Using the sum and difference identities and using the special angle strategy of the special determining function of special angles in our previous videos. That's it. So that's why we need to know the identities, because you might be asked, what is this? Or in the case of differentiating, if the function is very complicated, then think of the identities, because the identities can help you to reduce it. Now, reducing the expressions of trigonometric functions by the use of the identities will lead you to find the derivative. So in the reducing is actually the ways to use the basic derivatives, fundamental identities, fundamental derivatives of trigonometric functions. Okay, so what else? What other? By the way, to sum up with the sum and difference identities, we have this one: cosine, sine, positive, negative, negative, positive. For the sine, positive, positive. So it should be sin, cos, cosine. For the minus, sin, cos, cosine. But it is minus, it's also minus. So don't forget this one. And the tangent again is theta plus beta, theta minus beta. If plus, this plus. Then denominator minus. But this minus, is minus. But denominator becomes plus. That's it. And the reduction formulas are the negative angle of beta cosine is just equal to positive. The negative of sine in an angle is just a negative factor of sine negative sign of the angle positive beta. So the complements of this cosine is sine beta. So vice versa, if this is sine, instead of having cosine, if this is sine of pi over 2 minus beta, the answer is the cosine of beta because they are cofactors. So another identities that we don't no need to derive in this video. So all you need to do is you can use the previous, you can use the double angle, you can use the sum and difference identity plus the Pythagorean identity plus sum algebra, then we can replace this one. Okay, so we can derive. For example, the double angle means what will happen if you're asked to find the cosine of this double angle. And we need, for example, in the problem, you need to solve this. How much is theta? So in that case, you have to break this into independent cosine without the presence of 2. So only way to do it is to use this identity. So the question is how you obtain this one. So as I've said, you can use the previous the sum and difference identities. For example, the cosine of 2 theta, remember, is just equal to the cosine of theta plus theta. So you can now use the cosine sense of cosine of theta minus sine of theta sine of theta. So this is the same, so that's why this is cosine square. This is the same, that's why it's sine square, so it's minus. Which means that the double angle of theta can be replaced by cosine square, but take note this is minus. Because if this is 1, plus, this term becomes 1. So for negative, if the sign of these two are different, then it is a double angle. Okay, now another double angle is this one. How do you obtain this one? So you can obtain this one by replacing this using the Pythagorean theorem. Pythagorean identity, the sine square theta, take note, is 1 minus cosine square theta. If you replace this with this value, then this will be the result. Twice the cosine. Because this is cosine and this is involved cosine, this will become twice the cosine. And it's minus 1. Okay, now we have also, now if you replace this cosine, you can also replace sine. You can also replace the cosine. Cosine square theta is equivalent to 1 minus sine square theta. So substitute it here, then the result becomes 2 sine square theta. So this again, these are derived coming from the sum and difference identities with the Pythagorean identity. So double angle identity. The purpose of double angle again is you can break this factor of the angle into a single angle only. So in this case, there's no presence of 2 here. So then you can be easily, if this will be the unknown, then there might be solution to the problem. Now for the double angle of sine is twice the 2 theta for example sine. This is 2 sine theta cosine theta. Okay. This can be derived in using the sum identity of sine. So theta plus theta, this is just the same as this one, but this is sin cos cosine. So they have the same angle, so it's twice the sin cos cosine, twice the sine theta cosine theta. That's it. Then we have also the half angle. The half angle of the cosine is 1 over theta plus minus. So again, these are the other identities. So these are helpful also. There are cases that you will encounter this one. So replace the half angle with this value, vice versa. And there are also product identity, but we did not include that. Okay, so that's all. Thank you for listening.